Welcome to this Esko Software Solution Demonstration Series. In this episode, we will be covering ArtiosCAD. All participants have been muted, and at the end of this demonstration, we will unmute for Q&A. Thanks for joining. My name is Bart Meersschaert, and I will be your host today. Stay tuned for additional sessions. An event calendar is hosted on esko.com Brand Solutions. ArtiosCAD is Esko's award-winning structural design software. It runs on Windows PC. In my case, I'm running it on a Mac, simulating Windows in a VMware Fusion. New designs, structural designs, can be created from scratch using the new design feature here. We can also use a canvas to create multi-part components that will be combined. Think of a point of sales display, for example. And Artios is really good at creating 3D mockups as well. So without further ado, let's go ahead and give you a high-level overview of ArtiosCAD. As I create a new design, the first question that the system asks me is, what board type would I like to use for this design? So you can see here I can select from corrugated or folding carton set. And notice also here that we have a vast library of other finishes available. For this exercise, we will be using an SBS 14. With this blank canvas, don't be intimidated by all these icons here on your left-hand side. Those can be easily customized. In order to do that, you could go into the option menu and use the tool layer option. Also here, you can see the individual tools available to create new geometries, lines, arcs, radius, rectangle, and so on. We also have con lines, which stands for construction lines. Those are help lines that you can create. And of course, once you have created a design, you might want to make changes. So all the tools in order to adjust, you will find right here. There are many more, but those are the most important ones. We also have text, annotations, dimensions, and we can also add graphics to our design here in Artios, but I would recommend doing that later on in Adobe Illustrator, and we'll show you how easy it is to do that. Creating a new design from scratch, I'm going to use my rectangle tool, and then notice at the bottom of the screen here, you will always have feedback. So I'm starting to draw here, and let's say we are drawing a first panel. Let's say we create a sleeve that is going to be 5 inch. So I type 5, enter, and then I type my 15, my Y direction, and I hit the enter key, which creates that first panel that you see here. So now my second panel here, I could enter manually. So let's say this is going to be 1, enter, 15, enter. And then again, we have 5, enter, 15, enter. So you can see that you can build these sleeves manually. This is what I'm building here. If I want to add a glue flap, I could start using my construction lines and create a line from this point right here under an angle, and then use my line tool to create that. Another way to do that would be to use a predefined tool set, and that is called right here in design. Let me see. Let's go to tools, and we go to geometry macros. So think of macros as predefined individual elements like graphic symbols, for example, positive or negative here, hooks, handholds, for hangers. You know, if you have to create these perforations in your graphic design, you can do that. I want to use a glue flap. So if I pick that glue flap, I can see the depth of that glue flap, or the height, if you will. And in the next screen, I can see the width of that. So let's pick half inch glue flap. And then notice here that you can easily position that and it'll snap to that point that you click on with the positioning tools. So as I place this, we can use these tools here to zoom in, zoom out, and pan in our design. You can see that one of these lines is indicated as a red line and the other ones are all black. So what is that all about? Well, as we design structural packages, the type of line becomes very important to indicate later on in the workflow for cutting tables, for example, or when we make 3D, which line has certain properties. So in order to do that in Artios, we have layers. You can see here we're working on a main design layer. And then we also have a concept of properties, line properties. So here you can see all the generic line properties that we can assign to lines, and special rule types on the right, and then recently used ones. So crease lines, those are the ones we want to use for these two right here. And so once my design is ready now, I have a sleeve. I can now, I still need to add one more area right here. So in order to reposition my starting point, go ahead and use Control W shortcut to reposition your starting point, and then again specifying, I believe it was 1 inch, 1 enter, 15 enter. We now have a glue flap that we can join, and again specifying that this line needs to be a crease line. Doing so, we now have a finished sleeve. What we can do as well is provide additional information for the recipient, and for that we can start using these distance tools. So we have temporary distances we can add angles and radius. So let's use this one right here. Notice that as soon as I pick the distance dimension, the software automatically will place those elements on their own layer, and that's just fine. One click here, followed by an angle, followed by a second click right here, and then pulling out, I can now position that line like so. So again, one click indicating my angle as 0 degrees, second click, and then pull out. So you'll get used to that. Also, always keep an eye on the information here in the lower left-hand corner. Once we are done creating our dimension layer, we can fold this up in 3D right here in ArtiosCAD, and for that we use our 3D convert to 3D option here, shortcut Control 3. As you click on that, the software will ask me what is my base face. So that's the face that will lay flat. Let's assume that that will be this part right here. Click on the OK button, which now gives me a flat three-dimensional view. And at this point, I can now use these tools right here to fold the angles. So I can fold the angles one by one, or I can fold all of them. I can do that simply by double clicking, which will fold this to 90 degrees. And I can see here that I made a mistake as I placed the geometry macro. There was still a cut line underneath the design. And so here you can see we can go back, and that was this line that was hidden underneath the fold line. So if I delete this, you can see we'll try and fix this. So I delete this twice. Let's go ahead and undo once. So there's an unlimited undo in there. So once I have my final design, again, I can hit that 3D button. This time I can say update my 3D, pick that base face, and my existing design is now updated. I can get rid of this part and use the fit in view. I can use the little camera icon, which is shortcut Z, to rotate this design. And again, using the single fold, I can click on this and specify here using the slider the fold angle for that information. So you can pick here from standard angles. And as you're looking at your sleeve that you just created, you'll be able to also see that you can visualize your 3D model with different visualization modes. And here I'd like to draw your attention to, let's zoom in a little bit again and use the camera view angle. You can kind of see here all along this panel that my one fold for my glue strip, which was set to 90 degrees, coincides with the same angle that was set here on this view. So we essentially have two panels that are fighting in that same Z-plane. So in order to prevent this from happening, we have built in this really easy tool, which is called flap priority. So clicking on this tool, I can now click on either this flap or this flap. And as I click through this, I can set which flap should have priority, and that will actually tuck it in. And that's just a good standard operating procedure to make sure that your flaps are set properly. And as we peek in, we can see the glue flap being on the inside now. And that will become also important once you transfer this data to our Esko Studio application, which are plugins for Adobe Illustrator, when you generate high-resolution 3Ds from there. So my first example is finished. This was just manually designing. Now, obviously, ArtiosCAD has much more intelligent ways to quickly create structural files, and that is done using the standard tools. So what are standards? Standards are designs that have already been created ahead of time. And as you can see here, ArtiosCAD comes with hundreds of different designs. They're all located here in this catalog. And here we're looking at a top tuck on second as an example. But feel free to browse through this catalog, which will reveal standard brown boxes like FEFCO shipping boxes. And I also would like to draw your attention to the fact that these standards are parametric. That's very important because that means that you are able to repurpose these standards for different dimensions. Notice length, width, and depth are parametric here. And apart from picking these from this catalog, you can also create your own parametric standards. There is a special demo that we will organize in one of the upcoming sessions where we will show you how you can do that. That is rather complex because there's a lot of dependencies between different flaps, but it's worthwhile spending time to generate standards if you have repetitive type of designs. So let's go ahead and pick this top tuck on second. After picking my board type, you can see that the parametric design here allows me to enter my dimensions, length, width, and depth. So if also, by the way, you want to use fractions, you can use this green icon representing a calculator where you can pick from predefined standards. So if I wanted to do 8 1/4, I can do that like so. 8 space and followed by a space and 1/4. There you go. Yeah, 8 plus 1/4. Anyway, let's go through the next. So you can see that the design here also has other additional parameters. We have already assigned default values to that. So the only thing I have to do is specify these three main ones, length, width, and depth, and my design is ready. Remember, we were looking at the layer interface. Most of these predetermined designs already come with 2 additional layers, like a dimension layer and an overall dimension layer. And all this information will be retained once we save this file and pass this along to Adobe Illustrator. Once we pass this along to the graphic designer typically also needs some additional information, such as varnish free areas, and very important as well is bleed. So bleed lines, I would always recommend to create these around the entire outline of the design, depending on whether these flaps are printable or not. Typically, we want to include this. This becomes important when we start stepping and repeating these out on a manufacturing layer. The bleed feature is included right here, and the input again is performed down here. So if I would say, hey, we're just going to get a 1/8 of an inch bleed, you can see that line popping up around it. So again, I can decide to click on that to bypass certain panels, but I would not do that. I would always go totally around the outside circumference, and then you can confirm by clicking on the OK button. And that will then create that additional outside bleed layer, which can be visualized or hidden. So very easy as well is indicating varnish free or coating free areas. Right here we can give a internal and an external keep away. So I'm going to do an 1/8 and minus 1/8, and then you simply click in the flap that you want to keep varnish free. So in my case, those flaps right here should stay varnish free, and you again click on the OK button to embed that information in the design. Last but not least, we have what we call an artwork panel layer, which you can find here, and that's part of this toolbar. Again, if you can't see it here initially, you can always go inside your design right here, and you can access those tools again here as well. So that's in the annotation layer artwork panels. So artwork panels will indicate the direction of the art and which panel is which. Again, great information for the graphic designer. You can click on this, set all the required parameters for those panels and tolerances, and then finally bake that information into the design by clicking on the OK button. I could decide to also check my 3D as we've done before. I can create a new 3D file indicating my base flap, clicking on OK, and seconds later we can see what that tuck top on second would look like. So that easy to create designs. Sending the designs over to my graphic designer here in my company, I can do by saving my design. Let's go ahead and save it on the desktop and call it demo and save it. I could then email it, or even better, join us in another demonstration, in an upcoming demonstration where we talk about ArtiosCAD Enterprise, where you can save these designs in the cloud and all your stakeholders can access that same information from the cloud. Switching over to Adobe Illustrator right here, we can see that using this plugin from Esko called Place Structural Design, we can now place this file inside Adobe Illustrator and we can start working on this design. So in the layer menu in Adobe Illustrator, we can see that all the information that was added in that ArtiosCAD file is retained, and I can now start creating my art on top of that and quickly, using my Studio Designer, quickly see the very first moment of truth when graphics meet structure. And from here, I can then export this information as a TIFF file or a movie sequence and other output formats. That just quickly on how to send ArtiosCAD files into Illustrator. I did mention that you can add graphics as well here in Adobe Illustrator, but you are rather limited to the output resolution and the flexibility as far as adding these graphics, but that would happen right here. Okay, so far we have seen how easy it is to manually draw using these construction lines and tools that are provided here in ArtiosCAD. We have seen that we can use a much more sophisticated way to generate designs using standards. Now let's kick it up a notch and show you that we also, as structural designer, can access a display store. So what is a display store? The display store is a store where you can access hundreds of different designs. Most of these come at a fairly reasonable cost, anywhere in the 40 euro average price range. And here you can simply download these designs and change again the dimensions and quickly create beautiful structural point of sales, dispensers, you name it. So there are tons and tons of designs in here. There are also some free ones in here. You can access those by activating the free one and then searching for that. You can also, search on specific categories. Once you find something you like, you can go ahead and look at this design, so it'll show you what it looks like, and then right here you can simply download it and open it up in ArtiosCAD Enterprise or ArtiosCAD, and you can start again changing those dimensions. So once your dimensions have been set, and let's say you change your mind, you can go ahead and go back to your project and your design right here, and you can go ahead and rebuild your design. So this is also a nice functionality inside Artios, that once you have set all your parameters, there's no need to worry. You can always go back and go through that design process and say, okay, instead of 5 inches, we want it to be a little wider, so let's do 7.5, and we okay that again. This now impacts some other variables right here, which I can decide to ignore or not. In the case of other panels or coding-free areas that were added, I can come in here and I can decide to delete those layers and redo that. But you can see how I quickly changed my dimension here from 5" to 7.5". And then updating that 3D again is a simple click of a button, and now we have a 7.5" width. So very interesting, very powerful to go back and forth. I have been working in inches, so also here on the top of your design you can see some additional icons. We have talked about the layer menu, we have talked about the different styles of lines which are assigned. We have looked at the 3D right here, convert to 3D. I like to draw your attention to these last icons here. So if you're joining us from Europe or other parts of the world using the inch or millimeter, you can go ahead and change the dimensions right here on the fly. Notice how the software automatically updates the dimension layer as well. This one here, blade down or blade up, is more important for Kongsberg cutting table design, where you can see what your design looks like, especially with very thick foam or reboards, you know, V-shaped notches that you create in there. You can look at that from the top or from the bottom. And then here you can flip the side to change the print side from inside to outside. So that means that ArtiosCAD also allows you to create designs for inside printing and outside printing. This icon here indicates the flute direction or grain. So whether that flute runs horizontal or vertical right here. Again, more important in the case that we're working with corrugate designs. And then here I like to draw your attention to the pre-flight menu, which we recently added to our ArtiosCAD software. And this allows you to check your design and make sure that it is easy to manufacture it. There are no violations against any of my pre-flight parameters as far as drafting tools is concerned, folding parameters, gluing parameters, stability, and then press performance and slaughter and score. So these are all settings, parameters you can build ahead of time. The software comes with a lot of standard pre-flight profiles, and those are very powerful in order to make sure that your designs are delivered perfectly. Okay, so one last thing we'll mention here for today's session are some additional plugins that you can also acquire. One of them is the Palletization plugin. So if I look at the 3D design and we make sure that 3D design is folded up like so, let's take our sleeve that we created earlier. We can indicate here our pallet size. So if we pick a standard North American 40 by 32" pallet, we can pick that, and then we can create a palletized design. So here we can take the single object, so the single sleeve, and we can palletize that. More realistically would be where we first create a secondary shipper using the Arrange Design group, where we pick, for example here, a standard brown box 201 shipper, indicating the corrugate. Let's do an E125 flute on that, indicating how many we want per container. So let's say between 24 and 48, or you can really narrow it down by keeping minimum and maximum the same. The carton weight, the solid weight with the object in it. So this can be set again in pounds or kilograms, maximum height of my pallet, and maximum weight. So once we hit the OK button, CapePack, as a plugin for ArtiosCAD, will now calculate what that second shipper is going to look like based on the parameters that I specified. So here we can see that the system has automatically swapped length and width. That is fine. And depending on the dimension, we can see here that the software has created a total of 840 units right here. So it's created a FEFCO 201 with 20 units in one shipper. Notice the length of that shipper, 35 inch by 15 inch. And I believe I can also lift the cover at one of these to show the inside corner view. So once you are happy with this, you can go ahead and use the export and exit, which will then take that FEFCO 201 brown box that it determined and right here create that for you. So now you can quickly create a new 3D or add it to the existing one and fill it with the primary design and indicate the base face. And seconds later, you then have your final shipper right here ready to include those 20 primaries into this shipper. So very easy to create, secondary shippers around a primary design. That we can also do, as a matter of fact, in the beginning of the workflow. So if you would have any type of 3D model and you want to create packaging around it, ArtiosCAD is very strong when it comes to those types of workflows. So starting from a Collada file or an OBJ file, from a Siemens or a Parasolid, SolidWorks, Katja, ProE, IGES step file, VRML, CFF2 or DXF file, it doesn't matter. We have import routines here for all those different designs. So let's say, for example, we have a bottle design right here. We can go ahead and open that. Make sure you are on a specific view. So here we can see this bottle that was just imported. And then creating packaging around this, we can do by using our bounding box tool. So the bounding box tool is going to define a three-dimensional cube, an area around this package that this bottle where I'm trying to create a package for. So we can use this recenter tool right here by spacing this out. So you can stretch this. Let's see, so we could do a parametric, so scaling it on both sides in the same direction. One thing you definitely want to do after you bring in this model is first look at the dimensions, because sometimes coming out of these 3D programs, your scaling factor might have been set like totally off, right? By a factor of 10, 100, or in my case, by a factor of 1,000. That's where I started seeing that the dimension was so small that my object is actually 3 thousandths of an inch X, Y, and Z. So no worries. What I can do is in a first step, I can select this object and I can use my scaling feature right here. So scale design. So I don't have to go back to my 3D model designer right here. So I'm going to scale this up uniformly by a factor of 1,000. And we are going to OK that. There you go. Much larger now. So let's zoom out. Let's zoom out, way zoom out. There you go. And now I have the capability to do that bounding box tool that I was going to show you earlier. So now we can go ahead and stretch this on both sides. We could do this here symmetrically, and then we can rotate the design, do this once more for the X direction, and now we can follow this up with our run standard tool as we have done before. So the run standard will then ask me to indicate the length and width direction of the design. And so we've done that before. So with this, we'll come to the end of our demonstration here. So we've covered a lot of basic tools, creating manual designs, using the standard design, and hopefully this will get you started and give you a good idea of the capabilities of ArtiosCAD. Join us in upcoming sessions for more detailed demonstrations around some of these features that we highlighted today. Thank you for your time and be well.